differentiate inverse trigonometric functions. I'm not going to explain how we get to the resultant. We're just going to use it. Okay, so we're going to learn how to differentiate inverse trigonometric functions and apply it to other calculus techniques that we've picked up along the way. So let's get into it. Okay, so here's the HSC formula sheet. Now, it's written as an integral, but obviously we know that integration is the opposite of differentiation. So we're going to go this way. So there's going to be a bit of that, and I'll explain very soon why there's only sine and tan. Okay, so here are the three basic derivatives that we have. So the derivative of y equals sine x is this, all right? The derivative of y equals cos x is exactly the same thing, except there's a negative here, okay? So that explains why the formula sheet doesn't give us cos. We've just got to recognize that if there's a, for the cos one, there's just going to be a negative in the answer. So we need to remember that, okay? So that takes a few practice. And then tan, slightly different. The derivative of tan is just this thing here. So these are the three basic trig functions, and they're not trig functions, they're inverse trig functions, and their derivatives. So please write these down. Okay, so how are we going to apply it? Notice that I've got the trig thing here, the formula sheet there, just so that's something you know you're going to have in the exam, so it can guide you. All right. Pretty simple for the first one. The derivative of that would just be 2 times it, the derivative of sine x. So it's 2 times square root of 1 minus x squared, which obviously equals 2, okay, of the same thing. Now this next one, we're going to do what we've done with a lot of things that we've been introduced to, and that we're going to have to use a little bit of a chain rule. So if you look here, there's an opportunity for a chain rule, so we're going to use it. So I'm going to go let u equal x squared, and I'm going to split my page in half. So I'm going to go du dx equals 2x, and I'm going to go y equals cos inverse of u. Now that means that dy du equals negative 1 over 1 minus u squared, okay? Now, dy dx will equal dy times dx, and we're going to have to put something in there, and it'll be du, all right? And luckily for us, we have those pieces of information there. So I'm going to go dy dx equals dy du is negative 1 over, oh, there's a square root there, by the way. Square root of 1 minus, and then I'm going to expand, I'm going to put this instead of u in this case. So I'm going to go x squared squared, all right, times du dx is over here, so that's just 2x. So it's going to be 2x there. So if we consolidate everything down, we're going to get minus 2x over square root of 1 minus x to the 4. Okay, so that's what dy dx equals. Now, as you can see here, all we're doing is that we're finding the derivative of the same thing, okay, and then we're multiplying it by the derivative of what we made u, okay. So I'm going to try do it without doing the chain rule in this case and see how we go, okay. So I'm going to go dy dx is going to be 3 lots of tan. Tan is 1 over 1 plus, and now x squared. Now our x is this thing in here. So I'm going to put 2x squared, all right. Now I'm going to multiply it by the derivative of this thing here, okay. Now the derivative of that is going to be, we're actually doing another little chain rule, and if you don't get what we're doing, you need to revise derivatives of exponential functions, okay. So we're going to go 2e to the 2x, okay? Now I'm going to put everything together. So therefore, dy dx equals, I'm going to go 3 times 1 times 2e to the 2x all over 1 plus, and I can consolidate this. I'm going to consolidate that by going e to the 4, and then I'm going to, 4x. All right. So there we have our answer. Okay. So, we can consolidate it a bit further. We go 6a to the 2x plus 1 plus e to the 4x. Now, if you look at this, it's looking a little bit more like your formula sheet, but let's keep going. Here, there's two different ones. Now, notice that it's a function of x times another function of x. So I'm going to look at a rule that we've used many times. It's called the product rule, okay? And I'm going to write it out. Y dash, and we always start with v. V u dash plus u v dash. And I'm going to give a space here, but I'm also going to give a space here. And I'm going to write what u equals 2x squared. So that means u dash will equal 4x. V equals x. V dash equals 1 over square root of 1 minus x squared. And now I'm going to put everything together on this side. So y dash v is just this. So I'm going to put that in. U dash is just this. So I'm going to times that together. Plus u is just this. And v dash finally is that. So we're going to multiply through by. Now we can make this a little bit prettier. So I'm going to go y dash equals, and it's going to be 4x inverse sine of x plus 2x squared over square root of 1 minus x squared. All right, so the same rules apply with calculus and all the other stuff, so just be mindful of that. Okay, now I'm going to do this one, like I'm going to use it as sort of a quick, this next one, I'm going to use like a quick sort of chain rule way of doing it. So I'm going to like do the derivative of the original thing and then multiply by the derivative. So I'm going to go, what dy dx is going to be the derivative of this, which is 1 over square root of 1 minus, and what's in brackets? X minus 2 squared, okay? Now I'm going to multiply it by the derivative of the brackets, which is a half, okay? So I'm left with 1 over 1 minus x squared on 4 times a half. Now I'm gonna come back to this one in a sec. And that's our answer. Because I'm going to look at our formula in a bit more detail and see how we go with it, okay? All right, let's look at this one in the from the formula sheet. So if I look at the formula sheet and I'm going this way, okay, I don't know if you saw that, I'm going this way, I can see that there's a thing here called a, and in this case it's 2. So if I go that way, I'm going to have to go 2 squared. So I'm going to sort of follow this formula, not really thinking about it. So I'm going to go dy dx, and I'm like, well, that's 2, so that's going to be square root of 2 squared minus f of x is the top thing, so that's x, isn't it? So it's going to be x squared, and then f dash x. Now, f of x is the thing at the top, and the thing at the top of this is x, and the derivative of that is just 1, okay? Now, I think I've answered the question correctly, but the problem is that it's a different answer to what I had in the previous slide. I'm just going to fix this up. It's going to be 4 minus x squared, okay? Which is a really pretty answer compared to what I have here. So let me show you that it's the same thing, okay? So what I'm going to do is I'm going to grab it, I'm going to copy it, paste it here, and it pasted a few more things, but we can just get rid of that and get rid of that. And obviously we are not working with this, so we can put a line through it. Okay, so are they the same thing? Yes, they are. What I'm going to do is I'm going to combine the denominator by making this a surd, or in other words, I'm going to put a square root under it. I know the 2, I can write it as square root of 4 times this. Okay, and now because everything's under square root, you can play with them all together. So I'm going to ski jump this through. And I get 1 over square root of 4 minus, now this 4 and this 4 are going to cancel out, and we get that same solution. Okay, so are they both the same result? Yes, they are. And in essence, when you get something like that, it's probably best not to work with your memory and to use your formula sheet. But it's up to you whichever way you want to approach it. Hopefully this makes sense. Peace out.